let's take a look at our arrays example in the arrays folder project within the core programming and use folder, and we'll see how we can work with arrays. We're working with an integer array and an object array. You can see the way that we implement that, way that we work with that. And then equals new integer, it's an array. Put the bound there or don't. Multi-dimensional would have a comma and then additional dimensions if you wanted to. You could initialize everything here if you wanted to. Notice that we have 5 to match this 5, and this doesn't have anything specified, but we're going to set up 5 values here, 5 elements within our array. So they work very similarly. We're using an integer and an object. Integers derive from objects. They're value types, but they derive from object like everything else. We'll see that in the object-oriented videos. As we move down, you can see that we're using the array int and the object array in the same way. We're just calling this print method here. It's obviously overloaded for integer and overloaded for object arrays. So if we look down further, we see that we have 2 functions. And you can see the functionality. We need to have the same type within our arrays, so it might be useful to work with object, and that's going to allow you to have advanced functionality. You see one of these static methods is an object array, and the other static method is a integer array. And we just use a for each. So for each is great to work with your arrays. The type is an object, and then my array would be what is passed into this method. So that's what we're using. And then we could just reference this here and then create a string that's going to get returned because that's a string type. So it's just creating a whole list that you're going to see in the output, doing the same thing for the integer. So you can see the functionality, how it relates to each other. Using an object over using an integer is how you're going to be able to do some advanced things outside of using the same type within, say, an integer or basic type, for example, primitive type. And for each is a great way to get at your data as well. So you could just type in the dot notation to see even more functionality from the int or from the object. You see that you can do copying, you can get the length, get the value for a particular index element, and you can do so many different things. Length is very, very important. So you want to look at these as you want to, as it becomes available. There are more advanced ways to work with the collection classes as well, not just arrays, but you can do a lot of different functionality. I encourage you to dive in and see the different things that you can do in more detail. So additionally here, we're using the copy to actually array.copy statically. We are taking this as the source, this is the destination, and then we're copying the first 3 elements from one array to the other. You can see how we can pass them back and forth between the types here because objects are the parent type of what this integer type is. This is a value type, but it's object. Everything is an object, so you can do that. Advanced functionality type things. And then we just output that. We just print out the values again, show you how they've changed. And at the bottom here, we're just getting the upper bound. Get upper bound is going to get the upper bound of whatever we specify here. When we're dealing with multi-dimension, we would have more than a 0 value. Of course, depends on what dimension you want to pick. 0 obviously is what we're picking here because this is a single dimension array, and 0 is where we start always, as I mentioned in the how the arrays work video. So if it was a multi-dimension array of 2 bounds, then you would have a 1 there, and that's going to give you the length. You can also work with the length, of course. But this is the upper bound, really. So it's not the actual length, but it's the last element. So you're going to return a 4, even though there are 5 elements here. 4 is going to be the upper bound because it starts at 0, whereas 5 is going to be the length. And we'll just take a look at the code. And there you see. Just prints out the array, like I said. Very nice and very neat. Definitely integers, but in the second example, we take these first 3 and copy them to this array. Very nice functionality. And then you see the last element, that upper bound of that single dimension, that's going to be 4 in both cases, because 4 is the last element, but there are actually 5 values.